So what I want to do is I want to kind of go over what a representative fraction is. So we're talking here about RF. And pardon my handwriting because I'm writing on an iPad. I'm not writing on the chalkboard or a whiteboard. So this is a challenge in itself, but here we go. Representative fraction, again, is something colon to something, okay? That's a colon. All right, so it is, as I said, paper to world. Okay, I look like I'm a first grader writing, but paper to world. So it's a ratio, representative fraction is a ratio of what you see on the piece of paper to what you see in the real world. So for example, if I have 1 inch equals 4 feet, okay? The double tick mark is inches, the single tick mark is feet. What do we know in terms of the ratio between 1 foot to 1 foot? I mean, 1 inch. What do we know the ratio between inches to feet? How many inches per foot?
12.
12. Okay, so the ratio of inches to feet is 1 inch equals, 12 inches equals 1 foot, right? But here we have 4 feet, okay? We have 4 feet. So if I get rid of that, I have to have inches on both sides of the equation. So to get 4 feet into inches, we always want inches to inches. We don't want any other unit. We always want something inches colon something inches. That's our ratio, okay? That's a representative fraction. So what I want to do is I have to determine how many inches are in 4 feet. So if I have 4 feet times 12 inches per 1 foot, 4 times 12 is 48, right?
Yes.
So I have 1 colon 48 is my representative fraction for that equation. So 1 inch equals 4 feet is 1 colon 48 as a representative fraction. Does that make sense?
Yes.
Anybody that's confused?
I have a question, but I'm not, because I'm not
Okay.
confused. But my question is, so it ends up being 1 colon 48. You have no inches, feet,
You have no
or
unit.
anything like that.
No units.
So how do you distinguish whether it's centimeters or inches or feet? Because I don't know how to explain it.
It's a ratio for what we're doing in civil. This is for civil. We're always doing a representative fraction is in inches. We don't usually measure in inches. This is a confusing topic, but for representative fraction in civil, it's the same unit on both sides.
Right, and I understand that it has to be the same unit on both sides. I'm just wondering if there's nothing to tell you that it's inches, then how do you know it's not miles or feet? You know what I mean?
Because you have to reduce it all the way to inches.
Okay, so it has to be at the lowest.
Yes.
So like you couldn't do centimeters, you'd have to do millimeters.
Centimeters, you have to do millimeters, but if you're doing representative fraction in standard units, we do not use metric in civil. So we always use inches, feet, miles, so forth and so on. We're never using centimeters.
So it will always be inches.
Yes,
Got it.
always. That's the smallest unit, full unit in civil is an inch. Okay.
Wouldn't the ratio go across all units? I mean, someone just put that in the comment chat as well, but the ratios would go across all units.
Right. But in civil, we're using inches.
Right, but I mean, you could say a quarter of an inch equals 48 quarters of an inch. I mean, it's
You always have to have one on the left-hand side and a number on the right. It has to be 1 colon something as a representative fraction. So you have to reduce it to 1. If you said, what did you say? What did you say, whoever said that?
it was Scott, and I said just quarter of an inch. But I mean, if you 1 centimeter would be 48 centimeters, 1 mile would be 48 miles. Ratio.
We have to represent a fraction, you're reducing it to an inch. That's all you're doing. That representative fraction has to be a 1 on the left-hand side with a colon and a number on the right-hand side. And that's your representative fraction. It's a ratio. So you have 1 unit on the paper equals 48 units in the real world. Here for civil, we're using inches. USA Civil does not use metric, correct. Caltrans used to use metric, but they found that nobody, I'm looking at the chat, they found that nobody understands metric in the United States, or the large portion of people in the United States, especially California, did not understand metric, so they had to switch back to imperial. So we use the engineering scale, which is in decimal feet. Okay, Dulce? Everybody else in the world uses metric. United States uses imperial standard. Okay? So you're gonna have 1 colon, whatever you have. So if you had, for example, 1 inch equals 4, miles, I want that in a representative fraction. I know I have to have 1 on the left-hand side, and I have to have something on the right-hand side. So representative fraction for this has to be 1 on the left-hand side always, and what the 4 miles converts to inches. So I take 4 miles times, does anybody know how many feet are in a mile?
5,280.
Very good. 5,280 feet per mile times, we know that we have 12 inches per 1 foot. So I multiply all those 3 things together, and I have 4 times 5,280 times 12. So that's 253,440. There's your answer. I mean, it shouldn't be a debate. It's just, it is what it is. Okay. All right. Okay. So moving on. So that's how you calculate it. And I put it in the Google Notes that it is a ratio designated by a colon, which means that both numbers on either side are in the same units. I should put the number colon. Okay. So that's it. Okay, so tonight's lecture is on civil math. It's pretty basic. So again, if you've not had math in quite a while, don't be scared. This isn't too big of a deal. Let me go back to my shared screen. All right. So we will talk about linear distances as we use in civil in the United States. Area that we use in the United States, because that's where we live. And volume, which is right here in the United States, okay? So linear, if I come to the handout that I posted on your Canvas classroom, here's various ratios that would be helpful for you to know or have access to. Now, because this is an online class, you have access to all your notes when you take a quiz or a test. Make sure you have this printed. You don't have to memorize all these things, but it is helpful to have this handy if you have to convert one unit to another unit. One ratio that's helpful to memorize if you're going to get into civil is, trying to do two things at once, is this guy, actually, yeah. Those two are very helpful to remember, but the others are just common ratios that we do understand in civil. Now, terminology is helpful to understand in civil, especially when you're talking about measurements. When you see this word called a link, it's actually a chain link. So back in the day when we didn't have any digital equipment, let me see if I can find an image. Survey chain. These are what they look like. So that is what a chain looked like. That's how they used to measure distances across miles and miles and miles of land. This is what they used, okay? And so if I come back to here, I'm sorry, where are we? Here, one link equals 7.92 inches, okay? You just have to understand that every link that you saw on that image, one of these links is 7.92 inches, okay? Just take it and we roll with it, okay? We don't measure with chains anymore, but on old maps, sometimes old maps are in chains. Where is my chat window? It's still really, okay, sorry. So yes, links are not used anymore. Chains are not used anymore. Okay, we all use digital technology now. Digital and GPS. GPS is digital, but that's another form, okay? But if you get into civil and you have to draw old maps from the 1800s or around the turn of the century, which exist, a lot of, or I would say all of them are in chains. So you have to understand if something says a property line is 10 chains long, it's really 66 times 10, which is 660 feet long. Okay, so you just have to understand that terminology. On maps that are after approximately World War II, then they went to miles. Okay, so pre-World War II was the chain typically, and then after World War II was the mile. Now they still had miles, but they didn't measure miles, they measured in chains for whatever reason. Okay, so one chain is 100 links. Okay, all right, and that equals 66 feet. Okay, because 100 links divided by 7.92 inches equals 66 feet. And that's how they came up with that. So one chain is 66 feet. 1 mile is 5,280 feet, which equals 80 chains. And as we all know, 1 foot equals 12 inches. Okay. Alrighty. Any questions on the linear portion? Okay. An area, when we're talking about property, is length times width if it is a four-sided figure. Okay. Now 1 acre is an area of land. Okay. So all of these, what we first talked about were linear distances, meaning from point A to point B, that's linear, along a line, okay? Or along a projection of a line going from point A to point B. Those are all linear measurements. Then when we have an area of something, meaning it is a closed box or a closed figure, then we can measure acres. So the ratio that you should know is 1 acre equals 43,560 square feet. Okay. These other two measurements here, we will discuss in great detail later on in the semester, but I'm just giving it to you now so that you have access to it. You won't be tested on it until we discuss it later on. But one section is 1 square mile, and 1 square mile is 640 acres. Okay. And 1 township is 36 square miles. So 1 township equals 36 sections. And again, we'll cover this all later on. But what you really need to know right now are what you see in green. Okay. So we have linear, area, and now we have volume. So volume is, you find the area of the object and then multiplied by the depth or the height, or however you project that object out, then you can have a volume of something. Okay, and I'll show you examples of that in just a little bit. Okay, so if I come here, feet mile area, okay, so we come down here. So for example, when we're talking about volumes, what you see here on this image is what we call a drainage inlet box. It's what water falls into in a parking lot. So you might see something like this image here in a parking lot and you don't know what's underground. Well, it's this typically. okay? The inside of this box is typically smooth, okay? So you can physically calculate how much water that storm drain inlet can hold at maximum capacity. Okay, so engineers go far beyond that when they do their calculations, but for this class, it's just important to understand how to calculate a volume of a certain shape. Now, I'm not going to give you irregular. Somebody have a question? Shutting a door. Anybody have a question? Okay. So you're trying to find the, all right, everybody's muted now. So you're trying to find the volume of the inside of the shape. And here let's just assume that's a cube. So we could physically calculate the volume of water that drainage inlet could hold before it overflowed. Okay, and like I was mentioning, the inside is smooth, so we wouldn't have to figure out any unusual shapes inside the box. Okay, so the water flows in from all directions, okay, into this box in a parking lot, okay? And underground would be this type of box. Now they come in all shapes and sizes in terms of how engineers want them designed, but we'll just keep it simple for this example, okay? What you see on the side, you don't need to really know what that means, but on the side, those are, it's like a template for those people that are installing the storm drains so they can know where to cut the circle for the pipe. So they don't have to estimate the size of the hole. These are already templated for them so they know exactly where to cut the concrete, okay? All right, so here's a cylinder, and in civil, the most popular cylinder in civil is a pipe, okay? So on a cylinder, we would first find the area of the circle, and I'll show you how to do that in just a little bit, multiplied by the depth of the pipe, okay? So how far this pipe extends in a straight manner, we could physically calculate how much water that pipe could hold, hypothetically, okay? There's always different ideas of how much air is on the top of the pipe, just right on the top surface. If there's any sediment, we're not worrying about that. We're just assuming that it's a very simple pipe, simple example, calculate the area of the circle and multiply it by the depth of the pipe, or the length, I should say, of the pipe. And that's how you would find the volume of water for that pipe, okay? We also see triangular prisms in civil. Now, when I say triangular prism, I'm not talking about a prism for refracting light. But if you use your imagination and you look at this triangle here, and you would draw another triangle back here somewhere, it would physically be a triangular prism type shape, 3D shape. So we use that idea to figure out how much water a drainage ditch could hold before it overflows. So the same type of calculation, you calculate the cross-section shape, which is a triangle, and I'll show you how to calculate a triangle in just a little bit, and you multiply it by the length of the ditch. This ditch, which has a triangular section, which kind of looks like a V, if you ignore the top line, We typically call this in survey and civil a V-ditch. So if you ever hear me say a V-ditch, that's what I'm talking about. It looks like a V on a cross section, okay? And then we have the trapezoidal prism. So if you think of the previous example, which was a triangular prism shape, okay? If you take this trapezoid and you draw another one down the line, okay? Then it would look like a trapezoidal prism. And that again will allow us to figure out how much volume of water this trapezoidal ditch would hold before it overflows. Okay, so in all the shapes that we deal with in civil, at least for this class, you have linear distance, you have area, and then you have volume of shapes that are polygons or circles. We're not doing spheres, we're not doing ellipsoids, we're not doing any of that beyond stuff. We're just dealing with triangles, trapezoids, and circles in terms of ditches, okay? Projecting volumes, okay? Any questions thus far? Okay. So perhaps some of this is a review for you, and if it's not, then by all means ask questions so you can start the homework, or I haven't posted the homework yet, but hopefully we'll post the homework shortly so that you can at least review this and attempt some problems. I'm posting some practice problems this evening, so be aware that those will be coming shortly, okay? So parts of a circle. One second. Parts of a circle. So this image right here gives you everything that you need to know about what I hope that you know about circles, okay? So the line in cyan is what we call an arc, okay? And in CAD, you've been exposed to arcs, hopefully. So that's what that is. A sector is defined by 2 radii. So a radius is from the center of the circle to the outer edge of the circle. So that's a radius. So a sector is 2 radii. Radius plural is radii. A radii or a radius connected by an arc is a sector. So this can be an area, okay, a portion of the circle. Diameter is 2 times the radius. So if you visualize the radius here and the radius here, that would be 2 radii. So 2 radii is 1 diameter of a circle, okay? The chord is from one point of the circle to another point of the circle drawn in a straight line. And the area that is created by that chord is a segment, okay? And lastly, the distance around the circle, all the way around the perimeter of the circle, is a different term called the circumference, okay? So let us do this. Let me take this. Share whiteboard, stop sharing. Yes. Okay. So first, if we're talking about a circle, the area, if we're just talking about the circle, and that's a horrible circle, but let's just pretend that's a circle, okay? So all of these examples are for the circle. The area of a circle equals pi r squared, okay? Pi is a ratio of the diameter to, I'm sorry, one second. I just lost my train of thought. Pi. Pi is approximately, when you ever see two squiggles, that means approximately the circumference of the circle divided by the diameter of the circle, okay? Which is approximately 22 over 7. 22 over 7 is approximately pi. Now, what I want you to use for this class, I've put in the Google Doc pi equals 3.141593. Use that number at the very minimum to when you're using pi to calculate something, okay? So circles are the only object that we'll use in this course that uses pi, okay? So whenever I say pi, that's what I'm talking about, is this symbol, pi, it's Greek, okay? So again, area of a circle equals pi r squared. Now r on this equation is the radius of the circle, okay? So for example, if I had a circle with a radius of 3 feet, okay? And I asked you, what is the area of this circle? Area equals pi times, parentheses means times, 3 feet squared. Well, 3 feet squared is 9, okay? And 9 times pi equals, area equals 28.27 square feet, okay? So I took 3 times 3, which is 9, times the ratio of pi, which is 3.141593, and that equals, in a long decimal, 28.2743. We always round to the hundredth, meaning the second decimal place, okay? Does everybody know how to round? Okay, so if we have 4 and down, so if we had, let's say, undo. So I came up with 27.2743, okay? This number is 4 or below, so we ignore it and we leave it as 27. If 4 was a 5, I would round up to 28. So it'd be 28.28. But because we have a 4 there, we round down, and it's left at 27. I'm sorry, this is 28. 28, 27. Okay. Okay. Now, again, for a circle, the circumference, which is again the perimeter of a circle, equals 2 pi r, okay, which equals pi times diameter, okay. Why do I say that? Because 2 radii equals 1 diameter, okay. So either equation works just fine, okay. Let's get rid of this guy. So if I said, what is the circumference of the circle? If, again, the radius is 3, so I would take 2 times pi times 3 feet. Always remember your units. So I have 6, 3 times 2 is 6, 6 times pi, and that's 18.8496 feet. Okay, so since the 9 is greater than 5, I round up, so this then becomes 85 feet. Okay, so circumference is perimeter, which means a linear distance. If you took the circle, broke it, and then laid it out flat on a plane, okay, it would be a straight line, okay? So it's a linear distance in terms of a measurement. So because there is no area we're talking about the distance around the circle, the unit is in feet. If we're talking about area of a circle, the measurement would be square feet. If we're finding the volume of a cylinder, it would be cubic feet, okay? Because we're multiplying units by units, okay? So if I was trying to find the volume of a cylinder, okay? And again, that radius, let's do a different one, 3.5 feet. And the length of the pipe is, let's say, 50 feet, okay? And I say, what's the volume? Okay, so the volume is essentially the area of the circle times the length. So you're finding the area of that shape, cross-sectional shape, multiplying it by the depth or the length of the pipe, okay? And here let's just assume we're talking about the inside of the pipe, okay? The part of the pipe that holds liquid. So here, if we change the equation to pi r squared, which is area, times length, that means the same thing, okay? So we have pi, and r is 3.5 feet squared times 50 feet, okay? And let's erase something so I can fit the number in. Hopefully everybody's following me. Speak up if you have questions. So I have pi times 3.5 times 3.5 times 50 is 1924.22 5. Okay, that's what I get. But the answer is not correct until I round it and then I throw some units on it. Otherwise, we don't know what it means. Okay, so if I get rid of this up here so that I can write the final answer, it would be 1924.23 cubic feet. Because we have, let's do a different color. We have this squared. So foot times foot is a foot squared, times another foot is foot cubed. So if I show you here, if I have foot times foot equals foot squared, and if I have foot times foot times foot equals foot cubed, okay? Another way of writing foot squared is SQFT. And another, which is square feet, and another way of writing feet cubed is CUFT, cubic feet, okay? You can only multiply the same units together. You can't have inches times feet times whatever, because that wouldn't get you anywhere. You always want your answer to be in all of the same, you want to be able to convert everything to the same units before you multiply, okay? All right. So that's circles. So you have circle. So we've figured out the perimeter of the circle, we figured out the area of the circle, and we figured out the volume of a pipe, okay? Assuming the circle or the pipe is perfectly cylindrical, okay? And we're just making those, we're just using those examples for this course. We're not making unusual size pipes or shapes. We're just gonna have a regular cylindrical pipe, okay? All right. No questions. Okay. So now we're going to move to polygons. So polygon means multiple sides. So in order for a shape to be called a polygon, it has to have 3 or more sides. So a polygon that has 3 sides is a triangle. You've seen all different types of triangles, okay? Okay. This is isosceles. I always forget how to spell it. S-E. Isosceles triangle means that all 3 sides are equal, okay? This is a right triangle because it has a 90-degree angle at the corner, okay? But I digress. The important things that we're trying to figure out for a triangle is, again, the perimeter. So if I have a triangle, the perimeter, the area, and the volume, okay, of that triangle. Perimeter is the distance around a triangle. The area is obviously area inside, and the volume would be projecting this out. So in terms of a V-ditch, that would be inverted, and it would look something like that. And you would find the volume of water that that ditch could hold, okay? The perimeter is essentially, you're just adding up the 3 sides. We're not using trig in this class, so therefore you'd be provided all three sides. So that one should be fairly simple. If that one was 1 and that one was 1 and that one was 1 foot, then the perimeter would be 1 plus 1 plus 1 equals 3 feet. Again, this is linear, so the unit is linear, okay? Now, if we had a example here, we had a triangle. Make it easy on myself. Let's say we call this the height. We call this the base, typically. Okay. That's the height of the triangle. That's the base of the triangle. The area of a triangle is 1/2 base times the height. Okay. Essentially because this is half of a rectangle or a square. That's why that is there. Okay. So if I said the height of this triangle on the left was, if I said h, oops. If I said h equals 2 feet and the base equals 3 feet, I would have 0.5, which is the same thing as a half, times 3 times 2. 3 times 2 is 6 divided by 2 is 3. So this would be 3 square feet. That would be your answer. The true answer, we always like to have 2 decimal places in civil. So actually the true answer would be 3.00 feet squared. Okay, it's more exact. Okay, so that's the area. Let's erase that stuff. And again, this is recorded, so it's all in your notes, which is kind of cool. So the area would be in, we said that was going to be 3 square feet. Area has square feet. Linear distance has 1 foot, okay? Essentially, this is feet to the 1 power, okay? And then volume, if we were doing our shape again, I could draw it no problem in CAD, but with my finger is not the best thing. But anyhow, this is our V-ditch, so it's going to hold water, okay? It's not a worm, it's water, okay? Here's our water in this ditch, okay? We want to know how much water this ditch can hold. So again, the area, or I should say the volume of that ditch is, so the volume is the area, 1/2 base times height times the length of that ditch, L. Okay, there's the area times the length is volume. Okay, so if we said that for this example, the height would be this distance, the base would be this distance, and the length would be this distance. Okay. Let's make that a different color. That's your height. The red is your base, realizing that it's inverted, okay? And your length would be the green. So here if we had, let's say that the height or the depth of the, the height of the V-ditch is, oops, height is 0.5 feet. Let's say the width is, or what we would call the base, is 3 feet. That's kind of a typical V-ditch. And let's say that the length is 65 feet. Okay. So the way I would calculate that again is I would have V equals 1/2. I'm at the end of my, let's come up here, running out of space. I would have 1/2. The height is 0.5 feet. The base is 3 feet. And the length is 65 feet. Okay, so I multiply those three things together. .5 times 0.5 times 3 times 65, and I get 48.75, and that would be feet cubed. It's a volume, so there has to be a 3 there. Okay. So linear perimeter is 1 unit of feet. Area, 2 volumes or 2 units of feet. Volume is 3 units of feet. Okay. So that's a triangle. Okay. No questions? Okay. All right. So then we come to a square. Okay. This is a square. Okay. Again, we have perimeter, area, volume. Okay. A square has all equal sides. So when I do this, that means all 4 sides are equal. Okay. So if I say a side, if I label a side as S, just for an example, okay, the perimeter equals S plus S plus S plus S equals 4S. Okay, so perimeter is 4 times a side. So for example, if the side is 5 feet, okay, the perimeter of this square would be 4 times 5 feet, which equals 20.00 feet. That would be our answer. Okay. Okay. So the area of a square the area of a square, since all sides are equal, that means the top is an S, the right is an S, the bottom is an S, and the left side is an S. Area of a square is S times S, which equals S squared. It means the same thing, okay? So again, if S was 5 feet, you would have 5 times 5 is 25, and the area would be 25 square feet. Okay, and I'm running out of space. All right, lastly, volume. If I get rid of this and I redraw it, if I have the square, again, just pretend that's a square, and a cube, pretending that all sides are equal, okay, meaning that this is the same as this, same as that, which is the same as that, which is the same as, they're all the same, okay? So the volume is the area of a square times the depth, okay, the depth. But on a cube, all sides are equal, right? So the volume of a cube is S times S, which is the area, and the depth is also S because they're all equal. So the volume equals S cubed, or S times S times S. Again, if the side is 5 feet, okay, we would have 5 times 5 times 5, which is 125.00.00, getting lazy, okay? 125.00 cubic feet. So that's for a square and a cube, okay? Alrighty, moving onward. Rectangle works the same way, except that one side, or I should say, 2 sides are longer than the other 2, okay? So the opposite, so that is equal to that, and that side is equal to that, okay? So if I, again, P, A, B. Sorry if I'm putting you to sleep, but this isn't necessary for everybody to know, okay? For those of you that already have had this before. If you haven't had it, great, okay? Okay, let's just call the top line a width, because that's the width of the rectangle, and the shorter line the length. Okay, you could call it the height, you could call it whatever you wanted, but let's just keep it simple, L and W, okay? So the perimeter for a rectangle, if we say that the top and the bottom are equal and the left and the right are equal, we would have W plus L plus L, okay? We could simplify that by saying, how many W's do we have? We have 2 W's. And how many L's do we have? We have 2 L's. So that's what the perimeter equation looks like, okay? So here, if we said W equals 4 feet and length equals 3 feet, okay? Obviously, it's not to scale, but we'll just go with that, okay? So if we say 2 times the width, which is 4 feet, plus 2 times the length, which is 3 feet. 4 times 2 is 8. 3 times 2 is 6. 8 plus 6 is 14. So the perimeter would be 14.00 feet. Okay? Okay. Area is length times width. So the area of a rectangle is length times width. So if we have the length as 3 feet and we have the width as 4 feet, that equals 12.00 square feet. Okay? Okay? And again, volume, you're just multiplying it by the projected length or the depth. So if I had, again, this rectangle and it was projected out, where you might see this, we might call this a slot drain, S-L-O-T-T-R-A-N, okay? Slot drains are typically rectangular. They're hollow in the middle. They usually go underneath a curb. So if there's landscape on one side of a sidewalk and they want to transfer the water from the back of the sidewalk through the curb and into the gutter, okay, they usually have a slot drain of some sort that allows the water to pass from the landscape area to the gutter of a curb. Okay, so a slot drain is a common thing out in industry. And on your handout, I can put an example of a slot drain so you know what that looks like. There's all different kinds. Let me just do this right now. One second. There, I put it on your Google Doc in case you want to know what it looks like. Okay, so a slot drain, again, allows water to pass through. So we want to know the maximum capacity of that slot drain and how much water it can hold. So again, we take the area. So the volume equals the area times the depth. Okay. The depth of that structure. So the area is length times width times depth. So let's say the depth is 20, not 20 feet. Curbs aren't that big. Let's say 5.5 feet. I mean a sidewalk. Well, sidewalk plus, yeah, sidewalk plus a curb. Okay. So let's say so our width is 4. Our length is 3. Our depth is 5.5. And our volume would then equal 4 times 3 times 5.5. 66 big ones. 66.00 cubic feet. Okay, cubic feet. So that's the rectangle. So that's approximately, so 66 cubic feet is approximately 490 gallons. So that's a huge, huge drain, okay? Now for a curb, I mean a slot drain going underneath a curb, let's do this a little more precisely. Let's do, so a slot drain typically can be usually 1 foot by 0.25 feet. And let's say the depth is, let's keep it the same, 5.5 feet. So the volume is length, width, 5.5 equals 5.5 times 0.25. That's a little more realistic. 3.8 cubic feet. Okay. And that is 1.38 is approximately 10.3 gallons. And I just used a converter on Google just so you can kind of visualize if you had a gallon of milk, how many gallons would that equal? So it's approximately 10.3 gallons, just so you could visualize how much water that slot could hold, okay? All right. Okay. Then we have,
Hey, Sean, before you go on, this is Scott.
yeah.
What do we normally see in, when we're looking at plans or creating plans ourselves? I mean, are people putting cubic foot as CUFT or as the foot squared, FT squared?
You see both.
I'm sorry.
I said you see both.
Okay. Okay.
There is no real set in stone unit that you'll see, but you do need to be familiar with both, and they mean the same thing.
Right. Okay, but there's no like kind of semi-standard, like
No.
80% of the time we use it. Okay.
No. And these are plans. Whenever you see volumes of slot drains and volume of water, that's more of a civil thing. So you would see that on a civil plan, civil engineering plan. Whereas when we're talking about acres, area of things and linear of things, that would be typically on the land surveying side of the spectrum. So these different structures that we're finding volumes of water capacity, that's an engineering side. And the acreage and so forth and so on are the land surveying side, okay? But units are units. So there is no real typical standard that you'll see volumes noted as. You'll see both, okay? Good question. All right, so on a parallelogram, parallelograms are an interesting thing. It's basically like a rectangle skewed, okay? So if we looked at this thing, the red would be a rectangle, and you squish it, you have a parallelogram. Parallelogram means the opposite sides are parallel. So these two lines are parallel, and these two lines are parallel, okay? Parallelogram also means that these two lines have to be equal in length, and these two lines have to be equal in length. Okay? If they're not equal in length, it's not a parallelogram. Okay? And the area of a parallelogram, typically we don't see many parallelograms in the industry, but I just wanted to expose you to this just in case. Actually, sometimes you'll find if you're in the industry and you come across a slot drain that's been squished by a bulldozer and they want to salvage it. Sometimes they still want to see they didn't know the area when it was a rectangle, but they still want to salvage it and figure out how much water it can still hold based on its squish. Okay. You still do length times width. Okay. But the length is essentially the height. So, or the width, whatever you want to label each one. So length, okay, and that would be the width, okay? Or what we did on the previous example, let's not confuse all of us. We did width here, and we labeled that length, okay? So if you can visualize that, that's the same as this guy in terms of the height, length, width, okay? So when it's squished, it's still the same area, okay? So here again, if we had the, oops, length is 3 feet, width is 4 feet, so forth and so on, you're going to find that it comes up with the same answer as we did on the rectangular equations. Okay, so I don't need to go through that. But anytime you come across a parallelogram in industry, you can either calculate it as you have it, if it's a true parallelogram, your area and the volume is still the same, okay? Trapezoid, two different types, same thing, okay? Trapezoid means that two sides are parallel. Let's not say that they're equal though. So this is parallel to this, and these are not parallel to each other. This is parallel to this, but these are not parallel to each other. Okay? So this is our trapezoid. Okay? Trap for short. So on your trapezoid, oh, I'm sorry, Amanda, you were asked a question like 6 minutes ago. I didn't see that. Do you want one or the other?
For the feet cubed or the feet squared?
It doesn't matter.
Okay.
Doesn't matter. Okay? It means the same thing. But thank you for asking. Sorry, I missed the question. Trapezoid. So on the trapezoid, again, we have perimeter, area, volume. The perimeter is, you're just adding up the sides. And for this course, I would be giving you all 4 sides. You wouldn't have to calculate it any other way, okay? So if we said that, let's get rid of this guy. for this guy. Let's say that this was 2 and this was 1.2 and this was, I don't know, 1 and this was, it looks about like 1.2. Okay, I don't know if it works out, but let's just assume that that works out. Okay. And I wanted to find the perimeter, I would just add up all 4 sides. So 1.2 plus 1.2 is 2.4, 4.4, 5.4. So that would be 5.40. Let's just say it's in feet. There we are. That's our perimeter. You just add up all 4 sides. The area is a little different in terms of the equation. The area is, wish I had more space, area equals the height over 2 times b over b. Okay, so h means height. So for this example, 1 is your height. Okay, the little b is the top base. So you're looking at the 2 sides that are parallel to one another. Okay, the top base is 1.2 and the bottom base is 2. Okay, all right. So if we did our handy dandy calculations, I would say the height is 1, so 1 divided by 2, okay? 1 divided by 2 times 1.2 over 2, okay? So essentially that is 1.2, gosh darn it, 1.2, if I multiply the top first and multiply the bottom second, it's 1.2 over 4. So that means 1.2 divided by 4 is 0.3. So the area would be 0.30 square feet. Okay. All right. Volume again is just multiply it by the depth. So here, if we had an example that let's do this. Did I do that wrong? Gosh darn it. I did it wrong. Thank you, thank you, thank you. Sorry, guys. The magic of eraser. I knew that didn't look right. Always go with your gut instinct. Okay, area. Let's try this again, even though I recorded it. Area equals h over 2 times b plus b. Okay, that looks better. Okay, so h over 2. So h is 1, so 1 divided by 2. 1 divided by 2 times 1.2 plus 2 is 3.2. So that would equal 3.2 divided by 2. And thank you for correcting me. I always want to be corrected if I'm doing it wrong. 1.6. That sounds way better. No. 1.60 square feet. Okay, and thank you again for letting me know. Okay. All right, so I got a text from a student. Let's see. Okay, so that's the area. There's your equation, the correct equation. Thank you very much. Okay. So it doesn't matter what you call little b and what you call big B. Okay. And then you can calculate the volume if it was what we would call a trapezoidal ditch. Okay. So again, if I get rid of this and I do trapezoidal ditch, okay, and again it holds water all the way throughout, okay. So we can say the volume is the area, so the area is H over 2 times B plus P times the depth, and that would be the depth, the length of the whole ditch, okay? So if the height was, let's say, the height was 1 foot, and the top width was 4 feet, and the bottom width was 2 feet, and the depth was 100 feet, just keeping math simple, what would the volume of water that this ditch could hold? What would that be? So I have the height. I have the height, which is 1 divided by 2. I always run out of space. So I have 1 divided by 2. The B and the bottom B times 100. So the volume of this trapezoidal ditch of water would be 1 divided by 2 times 6 times 100 is 300 cubic feet. Okay. Now, if we go one step further, okay, we go one step further and we said, you know, instead of putting water into this, whenever we measure water, it's typically in cubic feet, okay? The volume of water, it's in cubic feet, but the volume of soil is in cubic yards for whatever reason. I don't know why, okay? So if I wanted to know how much dirt this thing could hold, so again, if I say the volume of water is cubic feet, or CUFT, however you want to write it. But the volume of dirt or soil is cubic, gosh darn it, cubic yards. Not doing very well, am I? Still getting used to this iPad. Cubic yards. Gosh darn it. Okay. So volume of water is in cubic feet. Volume of dirt is in cubic yards. Okay. So we calculated how much water this ditch could hold. Okay. But let's say they were filling it with dirt and they wanted to know how much dirt it could hold. Okay. Well, it essentially could hold 300 cubic feet of dirt. But like I said, we don't measure dirt in cubic feet. We measure it in cubic yards. So another equality that we need to know is that 1 yard equals 3 feet. Okay. So we can convert 300 cubic feet to cubic yards. Okay. But you have to be careful about how you do that. You don't want to just take 300 divided by 3 and voila, you get your answer. That's not the answer. Okay. So here you say, because you have to have the correct units. So if we have 300 cubic feet, let's just write them out. I would just recommend students writing it out if you have to visualize it, okay? And we want to convert it into cubic yards. Well, we know that 3 feet equals 1 yard. We know that equality. So essentially I can then cross that out and I'm left with yard. But I have to do it 2 more times because I have to get rid of that one and I have to get rid of that one, okay? So again, I multiply it by 1 yard over 3 feet, and I can then cross that out and that out. And I do it one more time, 1 yard, hopefully I don't run out of room, 3 feet, pretty close. I can cross that out and cross that out. What am I left with? Cubic yards, okay? So whenever you have to convert cubic feet into cubic yards, you take your cubic feet and divide it by 3 times 3 times 3 is your magic number is 27. So you take 300 divided by 27. Okay, so every time you have to convert cubic feet to cubic yards, you divide your cubic foot answer divided by 27, always. So we take 300 divided by 27, and that equals 11.11 cubic yards. And there's your answer, okay? Is that on the notes page? That is not on the notes page, okay? That's why sometimes it's good to come to lecture or actually watch the videos, because I know some people aren't watching the videos. Okay, or coming to lecture for that matter. So, water is in cubic feet, dirt, soil is in cubic yards, okay? Alrighty. We got the trapezoid, we got the triangle. Okay, lastly, hopefully this is helpful, okay? If we had a shape, let's just keep it simple first. Let's say we have a square. Let's say that all 4 sides are equal again, okay? Okay, and I want to figure out how many interior angles there are, or meaning how many degrees is the sum within this shape, okay? A square has 4 90-degree angles. That's what makes it a square, okay? Plus it has 4 equal sides. So again, whenever you see a symbol like this in a corner, that means that that is 90. So anytime you see this on the edge of something, like for example on your O snaps, when you snap perpendicularly, that symbol will appear. This symbol will appear. That means because perpendicular is the same as 90 degrees. So, so for this square, we actually have 4 of these things, okay? You don't usually see them, that's just invisible, but that's what that means. So we have 90 degrees times 4 corners, which equals 360 degrees, okay? So that's how many interior degrees there are for a square, okay? Now, if we had a, let's say a pentagon, for example, okay? It would be a little more difficult to figure out how many interior degrees there are if we didn't have CAD. Okay, we'd have to do it mathematically, and you have to figure out all the angles, and we don't have that much time. So there is actually a secret equation out there. It's not too secret because it's on your cheat sheet, but n minus 2 times 180 degrees equals IA, interior angle, okay? So n is the number of sides of the polygon, okay? The polygon has to be closed, okay? So what that means is if I drew this correctly, oops, don't delete, thank you. All sides have to touch, okay? It has to close back in on itself. So it started there, it ended there. So that's what we call a, this is also not in your notes. This is what we call a closed traverse, okay? It closes on itself, okay? If you ever see a shape that is, and then I'll come back to what I was talking about. If you ever see a shape that looks like this and doesn't close on itself, we call that, anyone? Bueller? We call that opened traverse, okay? Meaning that it's open, it doesn't hold an area, okay? If I started walking from the beginning of the line and came around, I wouldn't end at the same point that I began. So it's open. It's open, meaning it doesn't hold area. The closed, if I start at one end of the line and I walk all the way around, I always come back to the same point in which I began. Closes on itself, so it's a closed traverse, okay? So that's just a side note. Okay, so the number of sides for a pentagon is 5, obviously. So if I take 5 minus 2 times 180 equals 3 times 180 equals 540 degrees, okay? So that's how many degrees are within this shape. It works for a shape that has 1,000,000 sides, okay? So that's a good equation to know. So put that in your library of goodies, okay? That's on your handout, Google handout, okay? Did I hit everything on the? Let's see here. So I put that picture there for you. Okay. We did parallelogram, trapezoid, triangle, interior angle. We talked about circles. We talked about the different types of ditches, pipe, drainage inlet. We talked about representative fraction. And don't get all worked up about representative fraction. It's just have one on the left-hand side, colon, whatever that equals, okay?